Hey Kayla, this is a question that you asked from the last quiz. What you did, you started off great. You did exactly what you needed to do. You did your limit as x approaches infinity, and you did your expansion. You foiled it out over x squared plus 2. Now at this point you said, in your text back to me, you said that you took the derivative of the power rule on the top and the bottom. That process is actually called L'Hopital's rule. And technically at this point, we don't know about it. However, it's not incorrect, and I'm not going to mark you wrong on doing that because it is a correct process. So I'm going to show you at this point, I'm going to split off. This is the way I was expecting you to do it at this point in the course. And then I'll do it your way, and then I'll explain why your last step was where the error came in. So at this point in time, the process that we did was we take the term, the variable with the largest exponent, and we're going to divide every term by it. So that was what I was kind of expecting. And like I said, what you did wasn't wrong, and I'll just explain the why here. So we go through and we divide everything by x squared, and what we'll end up with is 1 plus, and I'll write out more than I really need to here to explain it, over 1 plus 2 over x squared. So now as my x value goes to infinity or becomes absolutely enormous, anytime you have 4 divided by a huge number or 2 divided by a huge number, if you're dividing by huge numbers, they're going to get very, very, very small. So they're going to 0, which means that all I'm left with is a value of 1. Okay? So that's the process that I was expecting. However, as I said, you used L'Hopital's rule, which is not incorrect. It just kind of surprised me because I don't see people use it very often at this stage in the game. Now, on unit tests and final exam, I have seen people use it, and you're more than welcome to use it because it is a correct process. L'Hopital's rule says that we need to have 0 over 0. That's the only way you can use the power rule on the top and the bottom. We have to have 0 over 0 in our limit, okay? So as x goes to infinity and this x squared goes to infinity, they're getting very, 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 very huge, okay? And, kind of not lying to you, I'm not giving you all the facts. Use it if 0 over 0, or it goes to infinity over infinity. So there's 2 cases, and you have the infinity over infinity case. All right? So now when you go ahead and take this, use your power rule exactly as you did it, you had 2x plus 4 over 2x. Now, you went ahead and you canceled your 2x's. Now, you can't do that mathematically because we have addition here. All right, you have to be able to divide a 2x out of every term, so that's actually an illegal maneuver that you pulled there in terms of algebra. That's like saying, off to the side here, 3 plus 6 divided by 3 is equal to 6, okay? So that's kind of what you did there in that case. Now, regardless how you do it, you still have to do an analysis here. So as 2x, as this goes to infinity, we're still going to end up having to divide every term by x. It's a little bit nicer to work with, which means that this term is going to go to 0, our x's will cancel, and we still end up with 2 over 2, and you get a 1. Okay? So that is hopefully answering the question you asked. Either process is fine. And actually, one of the thinking tasks is explaining L'Hopital's rule to me, and you've got a leg up when you take a look at it and come up with a short video. So hopefully that explains what you're looking at for this question, Kayla. And like I said, if you have any questions, please ask, and I will answer them as quickly and as efficiently as I can. So anyway, have a great weekend, and we'll be talking.